packing my bags. Time is a drag. Smell myself to make sure I'm still there. I'm alone in the park with the saber-tooth shark and every pretty girl that broke my heart. Receding lines, broken dimes. Who's gonna meet their match this time? The makers at home, smoking a bone. I'm on my own, I'm on my own. These nightmares, nightmares with a repeating cast of characters. I don't wanna talk when my thoughts are true. I hate myself when I think like you, 'cause it's over, it's over, it's ancient, it's so old, it's ancient, it's ancient, it's so old. Let's call the whole thing off. Let's call the whole thing off.
Old friend, see you again. Say goodbye. I won't cry. Old friend, I'll see you again.
All right, so we're back. This is the second day of review. Last time we reviewed by looking at the final from 2018 or whatever it was. And this time we're going to look at the final from 2019, but only part of it, and I'm going to modify it as well. But what I wanted to do first is I wanted to look at an exercise, really quick exercise here. Because I've been seeing a lot of issues with the project, especially with the repeated transactions. Remember, the whole point of this end of the semester project is to bring everything together, including searching and sorting. You're going to have to use searching and sorting for a lot of this stuff, because if you don't, then tens of millions of transactions, it's not going to run at all if you're doing things inefficiently. So what I wanted to do is to illustrate the idea that I see a lot of people doing. Consider a bunch of integers, and we want to know how many of them repeat. Now, if this were not in order, I made this so that it was in order, but if this is not in order, then of course we could easily sort it. If we didn't sort it, then of course I would have to look at the first one. How many times does that appear? Right? 1, oh, it appears twice. Okay. 2, oh, okay, it appears this many times, right? But if I sort it like I have done right here, then I can exploit the fact that all the repeats are right next to each other, right? Here is an inefficient solution. So for int I equals 0, I'm not even going to complete this one. I is less than n minus 1, I plus plus, right? I'm going to look at each one, the ith one, and I'm going to look at the rest to see if it is duplicated, right? So I'll go ahead and go for int j equals I'll start at I plus 1 because, of course, I is not duplicated with itself. Or j is less than n, j plus plus, right? And I'll make a quick check here. If the array sub I is equal to array sub j, right? Then that's a repeat, right? Printf repeated %d and the line. I guess I will go ahead and complete this. I didn't want to, but go ahead. Demo. All right. Now I'm going to get repeated 1, repeated 3, 3, 3. Now I repeated this one for this time and this time. Did I screw up somewhere? I didn't get I repeated 5. I repeated 1. I don't know why I got 3 instead of the 2 that I expected, but it doesn't matter because this is a terrible solution. Imagine that n was not 9. Imagine that n was something like 10 million. This is going to run for 10 million times, which is not that bad, right? It's going to be noticeable a few seconds. But this is also going to run for about 10 million times in the worst case. 10 million times 10 million, you're at 100 quadrillion. Fine, half of that. 50 quadrillion. It's still not doable in a few seconds, right? This is not what you want to do. What I want to do is I want to exploit the fact that I've already sorted this. Right? How do I do that? What I'm going to do is I'm going to compare the ith value with the next one, right? The I plus 1th value. If they're the same, then I know that it's a duplicate, right? So let's try that. If a race of I is equal to a race of I plus 1, then I'll printf, printf duplicated %d and a line, a race of I. There we go. Okay. Now notice this is why I stop short. Why do I stop short? Because if I'm looking at the current one, I'm looking at the next one. Then when I get to the end, is there a next one? No. So I stop short by 1. Okay. This will give me something, right? As long as I do it correctly. There we go. And restore that. Right. Duplicated 1, 3, 3, 5. Right. So I've found all the duplicates successfully. And I've only gone through it once. So if this is 10 million, fine, 10 million times, minus 1. Right? But I'm off by 1 here. How could we take care of that? In fact, I'm going to be, what I want to do is I want to report both this one and this one. And then I want to report this one and this one and this one. Right? Well, I could, I could handle, what could I do? I could ignore the first time that it happens, or I could ignore the second time it happens. Or what I could do is another loop. Not another for loop that needlessly goes through all the rest, but maybe a while loop, right? So while the current, that is the ith value, a race of I, is equal to the next one, ... So while, and I'm going to take this if condition that I had before, and that'll be my condition for continuing, right? And I will say duplicated %d, %d. These are the index values that I'm going to print out, I and I plus 1, and the value, right? So that you get the idea. And not only that, but I'm going to go down to the next one, I plus plus. Right? All right. What is that going to do for us? Right? 0 and 1 are duplicated. There. 3 and 4 are duplicated. That's this one and this one. 4 and 5 are duplicated. That's this one and this one. But when I get to 3 and I compare it to 4, that's not duplicated. So I break out of this while loop and rely on the for loop to go on to the next one. 7 and 8 are duplicated in 5. So now I get the exact number of reports that I want. Right? And all I had to do was 2 simple for loops. Now, hopefully you can adapt this idea for your project. Okay? All right. And hint on the rest of the stuff, searching, sorting. Use everything that we've covered over the last few weeks to come to bear. Okay? Here is the final from 2019. Now, I'm not going to look at the entire thing. I'm just going to focus on this one because I want to actually modify it. Here's the basic idea that there are lots of text analysis tools. Sentiment analysis is one that I use all the time. I just cut and paste, say, my course evaluations, and were they positive, contingent on the word choices, right? Were they positive word choices or negative word choices and stuff like that. But of course, span detection, fraud detection, authorship fingerprinting, right? Was this play really written by Shakespeare? Given these other plays were definitely written by Shakespeare, was this one? Did it have the same structure, the same word choice? Those are all very, very complex ideas and algorithms. We're going to do something simpler. We're going one building block of all that is frequency analysis, character frequency analysis. So for example, if I have English text, the Z character is very, very unlikely to be used a lot, right? But the RSTLE, very, very high frequency here. 23 times I saw an R, 29 times I saw an N, right? So for all 26 letters in the English alphabet, doesn't matter if they're capitals, doesn't matter if they're lowercase, let's go through a text file and count up the number of times each one appears and report that as this count here. Then what we're going to do is we're going to put this through Shannon's entropy theory, or theorem, or formula, whatever you want to call it. It's a way of measuring information. Now, if I just had a bunch of random information, then I would expect that everything has a normal distribution. If it's just random, then a z is equally likely as an r, right? And so there would be high entropy. I never get that right. Higher entropy values correspond to random data, so that would be that would give a high entropy value. Low entropy values indicate very structured data. So if I have R's are very, very common, Z's are not very, very common, I have a mixed distribution. That means that there's a lot of information in that distribution. If entropy is information, so that's a way of measuring how much information is in a piece of data. Let's do this first part before we get to that part, though. Okay? Very, very basic. Let's open up a file and process it and count up the number of characters in it. All right, A through Z. If it has other characters, fine. We'll just ignore those, though. Okay? So first of all, I'm going to want to open up that file. File f is equal to fopen. Right? And we'll just go ahead and hard code it here, file.txt. Right? And we'll open it up for reading. Of course, if you were going to do this proper, you would make sure that I don't have this file, so this is obviously going to result in null, and I should do some basic null pointer checking here. Or better yet, I could go back to hack 10, right, and simply reuse a function that I already wrote to load up the entire contents of a data file, right? I don't have that luxury here. Do I have to? I'm not even going to go bother looking for it, right? It's a review. So let's go ahead and write it. So I'm actually not going to store it into a string because I'm looking at character by character by character. So I'm just going to go ahead and go through this file until read character and then count. Oh, this is an A. Okay, I'll increase a counter over here. Oh, this is a Z. Okay, I'll increase the Z counter over here. Oh, this is an exclamation point. Ignore that. Right? So for each character, in other words, I'm going to have to set up a character, char C, right? And while C is not equal to, do you remember how you determine whether or not you're at the end of the file if I'm using fgetC? Right? In fact, I'll initialize it right here. fgetC of f. Right? I'm getting the first character. So I'll move this down here. Start with the first character. While I'm not at the end of the file, but the end of the file is what? UF. Right? If you're using forgets, it's going to be a bunch of nulls, right? That when you get down to the end of the file, forgets returns null. Because this is a character, it's not a pointer, you can't return null. Null would actually end up being the null terminating character. So there's a special flag value called EOF. And I've got everything I need up there. Okay, good. So I'm going to process the character, but only if it is A through Z. Okay, so if it's an A, C is, or if it's a capital A, then I'll go ahead and increase my A counter. Else if, good idea, bad idea. If it's a B, or if it's a capital B. Remember, they're single characters, so single quotes. I will increase a B counter. I didn't even bother creating int A, B, C, D, E, F, G, blah, 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 blah. Who cares? Is this a good idea? Do you want to do this 26 times? No. Right? So first of all, I need to determine if it's a character at all, if it's an A through Z character. Do we have something to help us with that? In the what library? C-type library. There is indeed is alpha. RTM. At this point, RTFM, because now we're all mature programmers. Right? All right, is alpha. Alpha, alnum would be alphanumeric character, but is alpha is what I want. If is alpha of C, then it's relevant. Otherwise, it's not. Who cares? Move on. And get the next one. Okay. Okay. In fact, I'm going to also want to keep a full total here. Int total. starting it at 0. And so I have read a valid character that I care about. Well, I still need to keep individual accounts of A, B, C, D, E, F, G, L, blah, 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 right? So do I need 26 counters? No. What's a trick that I could use? "26 integers." Right? Cool. And you could also do something like this. It's kind of hackish, but you can do that, for the first one. But I'm going to make sure that they're all initialized to 0 properly. So for int I equals 0, I is less than 26, I plus plus. 26 you could argue is a magic number here. But if, well, I take it back. I was about to say, if you don't know that there are 26 characters in the, or 26 letters in the English alphabet, then you're probably not should be in the computer science 1 course anyway. But I'll re-amend that because I have several stories. Well, I won't tell them right now because this is a review. But if you want to learn, want to hear some stories about not knowing that there are 26 letters in the English alphabet in college, then come and talk to me. Anyway, so I'm going to initialize them all to 0. How can I use that down here? Right? I know that it's an alphanumeric character. How could I map A to 0? How could I map B to 1? How could I map C to 2, etc., etc.? Well, remember that the ASCII text table, ASCII values, these are nothing more than integer values, right? Now, we saw plenty of solutions that had 26 lines like this. And so it's not completely unexpected. But capital A here is 65. Right? Lowercase a is 97. So what I could do is I could take the integer value of that, subtract, let's say A, subtract 97, and that gives me 0. If it's a B, that's 98. If I subtract 97, that gives me a 1. Right? I do have to be careful here, though, because what if it's a capital A? I want it to first map to a lowercase a and then subtract 97. How could I do that? I could convert it to lower of C. Right? Or I could have done that to begin with. And what I'll do is I'll go counts sub C minus 97 plus plus. Cool trick. Right? Now I know that it's a lowercase letter, and I know that it's an alphanumeric character, so I'm good to go here. Right? After we're all done, let's make sure to close the file, and let's go ahead and report this now before we go on to the second part. So for int I equals 0, I is less than 26, I plus plus. Again, you could say that 26 is a magic number and then put it into a variable if you really wanted to. Okay, whatever. Right? What I'm going to do is I'm going to printf %C. I'm going to make it look like this: %C slash %C, and then the count, and %D. Right? I'll just make it look like this. Now, how do I get the capital version and the lowercase version? But I'm given 0 through 25, so I plus 65, I plus 97, that gives me the capital, lowercase, capital first, it doesn't matter, who cares. And then finally the counts sub I. Okay? GCC demo, make sure that it's syntactically correct, great. Now when I run this, of course, it's not going to work because I don't have that, that actual file there. What file was it? File.txt, so let's go ahead and create it. And there we go. And let's go ahead and fill it up with random stuff first. So random.org, I've seen a couple people mention this on Piazza. Great for them that they found this out. That this random.org will actually generate random data for you. Truly random data. I think that it uses cosmic background radiation detection. It uses something to seed its random number generation. So let's go ahead and get these 20,000 strings here. All right. And remember that that's truly random. So we would expect things to come out to, looks like a normal distribution, that everything is equally likely. All right. Save that. And let's go ahead and try it again. There. Looks like it's almost equally likely to me. They're all at about the 700s. Okay. And of course, over here, I could report a total as well. Printf total is equal to %d and the line. And what did I call it? Total? Huh. I called it what it is. Who would have thought? Right? So there's 20,000 characters. That's how many I generated, by the way. Remember that I generated 1,000 strings, each of 20 characters each. So that's another sanity check that I was able to count them all, right? Because I knew about the input because I generated the input. Right? If you're continuing in computer science too, we do this as well, but we do it in a more structured manner. It's called mock data or mockaroo or mocking. This is actually why the test framework that we use in this class, CMOCA, it's a mock-up, right? It's test cases, mock data. And you can generate that data just like we generated the data for the transaction project that we're doing right now. Somebody else generated that for us, but of course we massaged it into a form that was relevant to this course, to this project. Okay? I am convinced that this works. Okay? Now what I want to do is I want to actually do something with it, not just report the totals. So let's talk about entropy again. Again, high entropy corresponds to random data. So we should expect this to have high entropy, right? Low information, very, very limited structure, right? Everything falls apart, right? There's also interpretations of entropy for energy, right? Energy tends to get lost in a system to even out, right? And now you've got a normal distribution on the energy. But if you've got something that's really hot in a system that's generally cold, like a sun or like a heat source or in a cold room or something like that, then you don't have as much info. Then you don't have as much. You have more structure because it's all coming from this one source. With text, it means that you have actual English text, right? Because Z's are less common than R's. So what we can do is we can put this through Shannon's entropy formula, right? Each one of these X's are distinct symbols in the data sequence. And a piece of X is the probability of the ith symbol. So in other words, the number of times it appears divided by the total number of characters that you have. That's why I kept a total. Because all we have to do is take this number and divide it by that total, and that gives us our probability. Once you've got all 26 probabilities, you throw it into this function right here. The probability minus or times the log base 2 of that probability, sum those all up and take the negation of it, and you've got a measure of the entropy. So for example, hello world, that should give us an entropy of 2.84. This random data, that should give us much higher entropy, right? It should give us, I think, normalized, it would be 20,000. I want to say, let's find out, right? All right, so let's report the entropy now. In fact, what I'm going to do is I'm going to set up another double probs for probability, right? 26. And I'll go ahead and initialize that all. I don't think I need to do this since I'm going to set them later, but I'll go ahead and set all those to 0. Okay? I can't compute it right here because I'm still summing up the number of times that a letter appears, but I can compute it right here. Probs of I is equal to the counts of I divided by the total. Right? And then I can also print that out as a %f. And probabilities is what that variable stands for. All right, is that correct on line 31? Counts, okay, 26. It appears 26 times. Or it appears 804 times. divided by 20,000. What's going to happen? Truncation issue. All the probabilities would end up being 0. Right? So, a typecast there helps me out. Okay? Let's go ahead and compile this and run it again. There. Right? Those are all the probabilities. 3%, 3%. You'd expect that because, you know, 26. So you'd expect actually, you know, 2%, would you? That's actually kind of high, right? That doesn't sum to 1, does it? Take this. Here's a sanity check. They're all about the same. If I multiply that by 26, okay, it's close to 1. Right? Oh, 0.4. Okay, 0.04. I was thinking it should be 0.02 for some reason. That was just bad math in my head. Good sanity checks. Right? I was not sane. I was just wrong. All right, so there are my probabilities. Now let's compute Shannon's entropy function. I'm going to steal this. All right. Remember that's a running total. So what I'll do is I'll call it Shannon. Right. Give him some credit. Right. I'll start it at 0. Shannon plus equals. And then I use this formula right here. The probability times log base 2 of that probability. Right? So probability, probs of I, times log of probs of I. Man, log. Log F, and log L. Right? What is that? Natural logarithm. Is that the same thing as log base 2? Nope, that's ln. Now, it doesn't really matter. All logs are the same to within a constant. And the measure of entropy is still going to be the same. It's just that the scale of entropy will be different. Okay? So, how can I correct for that? What is the change of base formula? Do we all know? I don't know. Does Wolfram Alpha know? Change of log base formula. Change of base formula? No. Yeah, I was trying to get a mathematical symbol, but here's what it is. If you want to change it to log base 2, then you just have to divide by log of the other one of 2. That's it. There might be a log base 2 in there, but this is good enough. In fact, you could put this into a variable and be done with it if you wanted to. Right? All right. Printf. Shannon equals. Oh, and then of course multiply it by -1. Shannon times equals -1. Right? Remember that there is a -1 out front here. Right, to make it into a positive number, otherwise you're going to get a bunch of negative numbers. %f and the line, and Shannon. So let's see what we get out of this. Uh-oh. Math library. Include the math library. There we go. All right, that's pretty high. I think you divide this by 26, or the size of your character set or something like that to normalize it between 0 and 1. But that's not the formula that I have here. Right? All right. How high is that? Well, let's go ahead and make sure that this works by looking at hello world. Right? Now, this is not going to be exactly like in the handout here, because I think in the handout we're counting this space here. But we're also going to have an issue here. Let me go ahead and run it. I don't need to recompile it. I just changed the contents of the file. Not a number. Why? All right. Well, those probabilities were correct. But why is this not a number now? Log of 0 is what? is negative nth, right? Or not a number. So in general, if it doesn't appear, you don't include it, okay? So if counts of I is greater than 0, then we do this, right? Okay? And it shouldn't matter, the probability should be correct, right? Because world appears once and there are 10 letters there, hello world, right? The space doesn't count in this case. So the probabilities are correct, that is 10%, appearing 10% of the time. There we go, 2.64, which is close to this. It's going to be slightly off because, of course, this handout version was counting that space there. Good enough for me. Let's have another sanity check here though. Right? Let's just go to a random Wikipedia article on Moldy Peaches is the song that I played at the beginning. So Peaches, Wikipedia. There we go. We'll just take their history right here. First paragraph of their history. And gives us something larger to work with. Right? And run it again. Okay, high. It looks like it's pretty high. That's all right. Should be structured though, but you see that there are lots of A's, lots of E's, but 0 Z's. Right? So if you normalize this, it would work out a little bit better. Okay. All right. Questions on that exercise so far? All right. Disappointing, but I will go ahead and get rid of that because I want to do one more exercise. Not from the final exam, but from something that I am going to suggest that you do. So every year, in a normal year, the semester would go all the way into December. Every December, adventofcode.com releases a coding advent calendar. So of course it hasn't been opened yet, but it will be opened in a couple of weeks here. But that's all right, we can look at last year's. Or it started in 2015, so there's what an advent calendar looks like. Every day, there are 2 exercises that are released at midnight. And if you want to get on the leaderboards, of course, you're going to have to stay up till midnight Eastern Standard Time and be really, really quick at your programming. This is basically a programming contest. I've made the leaderboard on one exercise in 1 year, and that was it. They only make the top 100 people appear. But I haven't completed all the years. 2016? I didn't complete that one. I think I just got frustrated. 17, or I got busy. I did 17 and 18. What is 18? I did 18. But 19 I did not complete, but we will go ahead and start there. Right? I would usually do, in a normal year, again, these are released in early December. I would do them, I would live stream them in years past as review for the final. I think I might have done this one last year as part of the review, and we'll go ahead and do it again. The idea is that you can use any programming language that you want because it just simply gives you numbers as input, and it gives you, and your answer that you submit to the server is just a single number. So it's randomly generated, I'm sure, for each user. So each user has a unique input and output that they have to come up with. And it's always, you know, themed around Santa or something like that. All right, let me make sure. Okay, so let me zoom out here so it all fits. So Santa has become stranded at the edge of the solar system while delivering presents to other planets. He needs to launch a rocket to go save everybody, right? So fuel required to launch a given module is based on its mass. Specifically, you will find the fuel required for a module, take its mass and divide by 3, round down and subtract 2. So for example, a mass of 12, you divide that by 3, you round down. Guess what? We're going to use C, so we don't have to round down, do we? If we divide an integer by an integer, we can rely on truncation. Round down to get 4. but if in this case it's you round down by you divide by 3, it's wholly divisible. Subtract 2 to get 2. For a mass of 14, you divide by 3, but you round down, so you get the same value of 4, but then the fuel required is 2 because you subtract 2 off of that. For 1969, that's the year that we landed on the moon, right? We did, in fact, land on the moon. The fuel required is 654. Why? 1969 divided by 4. Round down, that's 492. Minus 1, 3. 1969 divided by 3. Round down, that's going to be 654, or 656, and then minus 2 gives you the answer 654. That was the answer, right? 654, right? Etc., right? So, what is the sum of all the fuel requirements of all modules? There's my answer, right, from last year. Here's my input. You can get your puzzle input here. Those are all the modules, right? Randomly generated numbers. So, let's solve this. Of course, I could put this into an Excel file and then do division by 4 and then subtract 2 and then just highlight them, right? And I could cheat that way. It's not cheating, right? But it's not going to help me for the second part. And it's not going to help you for a review. So, let's go back over here and put that in my file. I am going to cheat here in that I know that there are 100, and I want to get on those leaderboards. So I'm going to quickly. Actually, do I have block selection mode? No, I don't. Okay. Otherwise, I would have shown you something else. Well, find end of the line. Can I do regular expressions? Yeah, I can do regular expressions. Find the end of the line and replace it with a... Okay, here. I'll show you a trick. Replace that with a comma. Okay. Yay. What am I doing here? Int, foo, or modules. What did I just do? I made a static array, and I used editing tricks. I don't know how to close this now, but editing tricks to not even have to load it from, do file IO at all. Great. What I'm going to do is I'm going to move file.txt to data.h. There's a header file. And what can I do over here? Close the tab. I can now include it. Data.h. Hey, cool. Make sure that it worked. For int I equals 0, I is less than n. I will go ahead and put that into a variable. Int n is equal to 100. Right? I plus plus. Let's make sure it worked. Printf, %d, and the line. And, oh, now, what did I call it? Modules. Survive. There we go. G. Darn it. What did I do? Demo.h. So modules, int modules. Oh, there. Forgot my semicolon. Right, there we go. And of course I screwed up over here too. They should be calling me out on this stuff. All right, I'm convinced that that's the same. 13,500. 13,500. The first one is 109,506. First one is 109,506. Okay. All right, here's my total. Int total fuel equals 0. Initialize it to 0. Otherwise, total fuel plus equals modules divided by, what was it, 3? Relying on truncation, minus 2. Printf, total fuel equals %d, and the line, total fuel. I already had my, module sub I. I already had my solution from last year, 3216744. 3216744. Right. Day 1 is relatively easy. Day 2 gets harder. Day 3 gets harder. At some point, you're actually emulating a custom assembly language and hacking an assembly machine, or simulating games. It gets pretty complicated, right? It gets pretty challenging. That's why I probably didn't do that those 2 years. No, I'm not going to do this anymore. I'm going to go have some eggnog. So during the second go, no-go poll, there's always a second part. You get the first part done, you get a star. You get the second part done, you get 2 gold stars, right? And a pat on the back from your own hand. But the idea here, and I won't beleaguer you with the reading it all, if you send up fuel in a rocket, guess what? That fuel weighs something. So you need some more fuel in order to send up that fuel. That fuel weighs something. So you need some more fuel to send up that fuel, et cetera, et cetera, et cetera, right? So for each module mass, calculate its fuel and add it to the total. Then treat the fuel amount that you just calculated as an input mass and repeat the process, continuing until a fuel requirement is 0 or negative. For example, module of mass 14 requires 2 fuel, right, just like before. This fuel requires no further fuel because 2 divided by 3 rounded down is 0. So I think that magically you wish really hard and you don't have to use fuel for that anymore, right? But the more interesting one here is 1969. That requires 654 fuel. Divide that by 3 minus 2. That's 216 more units of fuel. But that requires fuel. So 216 requires 70 more fuel, which requires 21 fuel, which requires 5 fuel, and requires no further fuel, etc. Okay? Oh, I've already got my total fuel here, initially. Help me out. Get rid of this. Ideas. Probably some sort of a loop, right? While fuel is still required, here's your fuel. Here's my total fuel, right? Right. So let me. I don't want to lose that. So let's go ahead and save that off into another variable. Fuel, right, is equal to total fuel. Right? And that's going to go down, right? It's going to go down from the example here. I'll close that. The example was it's going to go down to 654, then 216, then 21, then 5. Okay. So when it gets down to 0 or less, then we stop, right? So while fuel is less or greater than or equal to or greater than 0, I need to compute more fuel. So int additional fuel for the fuel. That's a terrible variable name, but that's what I wanted to convey with that idea. Additional fuel for the fuel, right, is going to be equal to the current fuel that we have divided by 3 minus 2. Okay? Now, if that's negative or 0, I'm wishing really hard, right? So I don't need to do I'm going to make an immediate check here that if the additional fuel is less than or equal to 0, or less than 0, or greater than 0 is what I want, then I will add it, right? So total fuel plus equals the additional fuel, right? And what let me print some debug statements here too while we're going along, just to illustrate. Of course, I would want to run this in a proper debugger instead to see if I can repeat the example on the web page. So additional fuel %d and the line, and additional fuel. All right, cut, paste. There we go. So I add that additional fuel. Now, the fuel that I still have to account for is now that additional fuel. And I continue. Then I print at the end, printf, grand total is equal to %d and the line. And at this point, it's total fuel again. Okay? Make sure I didn't screw up here. There. Grand total 4825073. 482. Nope, I got it wrong. Back to the drawing board. All right. First of all, does anybody see any problems here? It was divide by 3 minus 2, right? Okay. I don't know. Those are big numbers. What's something I could do here? I could swap out the data, right? What if modules was just one number, 1969 instead? And over here, n was just 1. That would be that test case on the website, right? Int modules. And let's go ahead and comment that out. We can't have 2 modules here. G. Okay, there we go. So total fuel, that's correct, 654. 216, that looks right. Right? Remember that it's 216. Then requires 70 more fuel. All right, 70 more fuel. Then 21. Then 5. It looks right to me. Right? So, but the grand total here is 966, which is off by what? Oh, 966. It's correct. Damn it. All right, fine. Let's try this one. All right, 100756. 50346. All right. Oh well. I got both of those right. I just didn't get mine right for some reason. Wow. Now I am stumped. That I copied it correct, I think. Here's my puzzle input. Remember, we printed it out, remember? Oh! Wait. No. I don't think you have to do this for every module. Once you've got one fuel, then you're good to go, right? And restore this back to 100. Total fuel was correct. Once I've got the total fuel, I need to compute the additional fuel. Print that out. That was correct too. If it's greater than 0, then I add it, and fuel becomes the additional fuel. Okay, I'm stumped. (4825073). 5073. 5073 minus. So we're off by 2834. 2824. Nope. There's no hint there. Oh well. Whatever. Okay. I give up. I got it right that year. I'll have to look back at. I don't save this code, so I don't know why. I don't know what my mistake here is. If you know online, go ahead and let me have it. Otherwise, what I would suggest, especially over the break, of course you can't. You can go back to the old years, right? And all the events. Where are they? All 1, 2, 3, 4, 5 past years, or you can wait till December. After, of course, you're done with all your courses, after you're done with all your finals, then you can go back and stay frosty with all of your with your coding skills and do each one of these. All right. That's the end of the review. Let's talk about the final. First of all, how many people are online? All right. To reward those that have actually been coming throughout in person, as well as those who have been watching live, I'm going to tell you this, give you a present here. But before I do, I would ask everybody online and everybody in here, keep it secret. I want to see how many people have been paying attention. I will definitely announce this on Piazza, but I'm going to wait till Friday. All right? So, I celebrate Christmas, of course, but I also celebrate Crimbus. All right? And I'm taking this opportunity to announce as a gift, no final. So the way that this is going to happen is at the point that I announce this on Piazza, let everybody else do. Don't announce this on Discord. Don't announce this on Piazza yourself. If you have a close personal friend, you might want to say, hey, you might want to start watching those lectures, right? Because I didn't know how to do file I/O until I actually went to class or I watched the lectures to do it. So let's reward those people that have been engaging with the material. Everybody else will, of course, be rewarded, but they'll have to wait for 2 days here. And when I announce this on Friday, the way that it's going to work is I'm simply on Friday, I'm going to announce it, and I'm going to give everybody 100 points. And that's it. Everybody gets full 100 points, plus whatever bonus from the course evaluation. Okay. Oh, no reaction on YouTube at all yet. No reaction on Piazza either. Okay. Whatever. So, Merry Crimbus. Oh, thank you. There we go. Finally a reaction. Fantastic. All right, but again, shh, it's a surprise, right? Let everybody else be worried for another 2 days that hasn't been paying attention to the lecture or whatever, right? Keep it a secret. Yes. No. Well, if they're not, of course, if they watch the lecture at a different time, then of course they'll see this. They just won't see it live, and they'll know. But if they don't watch the lectures at all, then they'll sit and spin for another 2 days, thinking that they've got a final exam on Tuesday. Okay. All right. Edit this part out. Good idea. All right, any questions?
So, like, if we have no final, then the project's the last thing.
The project is our last obligation for this course. Of course, you still have Hack 14. Hopefully, you're at a good point on that right now because you use 14 for your project. But otherwise, yeah, that's it. This might not. Here, let me put this down because this might end up being like one of the splash screen for the video when it gets up on YouTube. All right. No questions?
Can you tell us that story about that student?
No, it's not my story. It's a story from a math person that I knew in the math department. This is many years ago, so it's no current student at all. But he was teaching a remedial math class, a math class that you don't even get college credit for. And they were trying to do, probability and like what's the probability of finding a z, the number, the 1 over the number of possibilities. And so he kept trying the number of possibilities. They understood the probability. It just after you were working with them for 10 minutes, he said that he came to the realization they didn't know how many letters were in the alphabet. No, that he didn't indicate that. No.
I mean, that would explain why he was in a remedial math class.
Precisely. Right now, 26 is an easy number to remember, but of course, I know that there are 48 hiragana. There are tens of thousands of Chinese kanji characters, right? In fact, I think the extended non-simplified Chinese, 40,000. If you include proper names, 60,000, if you something like that. Now, the phonetic alphabet, I have no idea. I don't know any Chinese at all. Korean, they got me there too. But I mean, if you learn a language, you probably know at least the phonetic alphabet and how big it is, right? Goated. All right, then again, great practice here, and it's also fun. Again, it starts out pretty simple, but then it can get pretty hard. Like here on, I forget what this was. Okay, there's an infinite sheet of paper. Say what?
Infinite sheet of paper.
Yep, starting in the top left corner, the codes are filled by diagonals. Infinite paper is covered. For example, the 12th code would be written as 4, 2. The 15th code would be written as 1, 5, column 5. Uh, Here, the 15th code. The voice on the other end of the phone continues with how the codes are actually generated. The first code is this. After that, each code is generated by taking the previous one, multiplying it by that, and then keeping the remainder and dividing that by that. So very, very large numbers here. And sometimes it's brute forcing it, and you just have to deal with it. Or sometimes you have to realize with some of them you have to understand like some advanced computer science. I wouldn't necessarily call it advanced, but like hashing functions, and realizing that some functions are cyclic in nature and so come back around. So he'll give you this astronomically large number, and what you have to do is you have to detect when a cycle is there, because that astronomically large number has you do computations over and over and over again, the same computations over and over and over again. And you have to realize when the cycle is there to take out that cycle so that you only compute a little bit to get the answer. Otherwise, he designed it so that it would take millions and millions of years. And you have to actually look at the problem, analyze the problem, and understand the problem in order to actually program it. But at the end of the day, the programming becomes simple once you've solved the problem. My puzzle answer was whatever that was, right? And then it got really complicated up here. Yeah, admire your advent calendar, right? I should have worn the. You could also buy merchandise here if you want. They've got a nice shirt. Oh, that's a new one. I have the original one. Okay. What does it look? Nope. All right, he's got new stuff this year. That's probably what the advent calendar will look like this year. Okay. There's nothing else? All right. Anyway, I've got a sweatshirt of the original one from 2015. How about the number of used Unicode code points? It's in my book. I wrote it like 3.7 million or something like that. I forget what it is. All right, then. Good luck on the rest of your finals. I would remind you that you do have finals because of the screwed up schedule. You do have finals scheduled for Saturday, Sunday, Monday, Tuesday, Wednesday. So you don't. It's not relevant to this class, of course, but make sure that you are looking at your final exam schedule and not missing a final for your other classes. I think the large math classes, I think they're on Saturday. Bring your N card to get into any buildings. Stay away from the football crowd. Wear your mask. Stay far away from the football crowd. All right. All right. Then have a Merry Crimbus.